For problem 6, we have find the center of mass of the semicircle whose center is origin and the radius is r and density equals 2. Here I have graphed a semicircle, and we know that for a circle, r equals the square root of x squared plus y squared. If we solve for y, we get that y equals the square root of r squared minus x squared. We're trying to find the coordinates of the center of mass, so that will be x bar, comma, y bar. And here we know that x bar is going to be 0 because it is symmetrical, and for when it's in equilibrium, it will be x equals 0. The formula for y bar is 1 over a, integral from a to b, 1/2 f of x squared minus g of x squared dx. From here, we can identify our area to be 1/2 pi r squared, since it is half of a circle. And we can say that our a is equal to negative r, and our b is equal to r. So we will have that y bar is equal to 1 over 1/2 pi r squared, integral from negative r to r, 1/2 times our function, which is our f of x, which is the square root of r squared minus x squared, the whole squared, dx. We can bring the 1/2 outside of the integral, and that will cancel these 1/2s. And it works out nicely because square root to the squared will just cancel out. So we have that y bar is equal to 1 over pi r squared integral negative r to r of r squared minus x squared dx. Now we can integrate, and we will get that y bar equals 1 over pi r squared x, because we have to treat r squared as a constant since we are integrating in terms of dx. And then we get minus x cubed over 3 with boundaries from negative r to r. When we plug in the negative r and r, we get 1 over pi r squared times r squared times r minus r cubed over 3 minus r squared times negative r minus negative r cubed over 3. From here we can simplify and we will get r cubed minus r cubed over 3 minus negative r cubed plus r cubed over 3. And here we can distribute this negative. And we can add the r cubed and the r cubed over 3 together. So we will get 1 over pi r squared 2r cubed minus 2r cubed over 3. In order to subtract these, I multiplied this by 3 over 3 in order to get the same denominator, and that gave me 6r cubed over 3 minus 2r cubed over 3, which simplifies to 1 over pi r squared times 4r cubed over 3. These r's cancel out, and we will end up having 4r over 3 pi. Therefore, our x bar and y bar coordinates would be 0, 4r over 3 pi. And that's your answer.